Graphical representation of the particle displacement, velocity and acceleration. We have already calculated displacement of particle at any instance of time is y is equal to a sine of omega t, right? Where omega is 2 pi over t, so y is a sine of 2 pi over t into t. So this is the displacement of particle at any instance of time. Now, when the particle completes one oscillation, it takes time t. It takes time t. This is known as time period. This time period we can break it into 4 parts. Initially, when it is at rest or equilibrium position, we take this time 0, and now when I stretch to this right, the time will be t over 4. Now when it comes back, then time will be t by 2. When it is compressed, time is 3t by 4. Again, when it comes back to its position, okay, then time is t. So this completes one oscillation. Let's calculate the displacement in these 4 cases. Number first, when time is 0, we check the displacement of particle is y is equal to a sine of t0, so it will be 0 and it will be 0. So when t is 0, this y is 0. Number second, when t is t over 4, when I stretch, when it is displaced, okay, to the right, then y is a sine of 2 pi t, and small t is t over 4, so we get y is a sine of 2 gets cancelled, it will be t gets cancelled, it will be pi by 2, so it will be y will be plus a. Okay, when t is pi by 4, t by 4, y is plus a. Okay, when time is t by 2, when it comes back to its mean position, time is t by 2. So time is t by 2, displacement is a sine of 2 pi over t into this t by 2. So it will be y a sine of pi, that is 0. So displacement is 0 when time is half. Number 4, when t is 3t over 4, when it reaches other extreme position. So y is a sine of 2 pi over t, 3t over 4, it will be equal to a sine of 3 pi by t. Okay, it can also recognize y is a sine of pi plus pi by 2, so y is a sine of pi by 2 but minus times, because sine pi plus some theta is minus sine of theta. Okay, so it will be minus a, because sine pi by 2 is 1, so it will be minus a. The amplitude will be maximum but in opposite direction when it is at other extreme position. When it completes time t, when it reaches again its main position, y is sine 2 pi by t, it will be a sine of 2 pi, then it will be 0. Okay, alright, when t is 0, this is the t when time is 0, and this is when it time is t by 4, this is t by 2, this is t by 4, then this is t. This is the complete time taken, and we divide it into 4 equal parts. Okay, now when t is 0, you see that displacement is 0, it is here. When t is t by 4, y is plus a. When it's t by 4, y is at plus a. So this, when t is t by 4, it will be plus a. Okay, when t is t by 2, when it reaches at half time, again this is 0. So it is when t by 2 times t by 2, displacement is 0. Okay, When time is 3t/4, displacement is minus a. It is minus a. So displacement will be minus a when time is 3t/4. Okay. Again, when you see when t is t, the displacement is 0, the particle will be here. Okay. Now let's join these points. If you join these points, we have this graph. Now graphical representation of velocity and acceleration. Velocity is y dot is v a omega cos omega t, or velocity is written as a omega cos 2 pi tt, and this is the acceleration, double differentiation of this displacement. It is minus a omega square sine 2 pi t times t. So let's go. When time is 0, when it is at mean position, then v will be equal to a omega, because cos 2 pi t is 0, cos 0 is 0, so it will be maximum. So when time is 0, when particle is oscillating, its mean position, at its mean position, it will be maximum. And here, if you see, it's minus a omega square, this sine 0 is 0, so it will be 0. Okay. When time is t/4, v will be equal to a omega cos 2 pi by t/4. It will be equal to a omega cos of, it will be pi by 2, cos pi by 2 is 0. So when it is at t/4, time is t/4, velocity will be 0. Okay. Acceleration will be minus a omega square sine of, it will be pi by 2, it will be minus a omega square. Acceleration will be maximum, but in opposite direction, but negative times. So when time is t/2, it will be a cos of 2 pi by t, this t gets cancelled, a cos of pi, and this will be equal to minus a. This is omega, a omega. Again, it will be maximum with negative sign. Alright, so t/2 acceleration is minus a omega square sine of 2 pi t, and t/2, so it gets cancelled, acceleration will be 0, sine of pi is 0. Okay. When time is 3t/4, velocity will be a omega cos of this, so it will be equal to a omega cos of 3 pi over 2, so it will be 0. Okay. And now in this case it will be minus a omega square sine of pi plus pi by 2, and it will be this will be minus 1, so minus and minus cancels, a omega square, then this will be maximum. Okay. And again here you see it will be equal to a omega, because cos 2 pi is plus 1, and it will be 0 because cos 2 pi sine 2 pi is 0. Okay. This is the data we have got for velocity and acceleration at different time intervals. Let's draw the graph. First, for the velocity, when time is 0, its maximum value is plus a omega. Okay. When t is t/4, its value 0. When half time, it is minus a omega square. When the time period is 3t/4, again it is 0. And when it is t, complete time period, is again plus a omega. Okay. Let's join these points. By joining these points, we get this beautiful cosine graph. Okay. Similarly, we can draw the points for acceleration for different time intervals. See, when time is 0, acceleration is 0. When time is t/4, it is minus a omega square. When time is t/2, it is 0. When time is 3t/4, it is plus a omega square. Again, when time is t, it is 0. Okay. So let's join these points. So this is the graphical representation of acceleration. So these are the graphs for velocity and acceleration.